In the second week of April, a new version of STAAD.Pro CONNECT Edition has been released with several updates in analysis, design and user interface, along with couple of new features. Do you know, in this version we can model a tapered wall with FEM, which is commonly used for a retaining wall, or design a web tapered section as per EC3 code. After a long wait, design of tapered member using Eurocode is finally implemented in STAAD. And not only this, there are several other important updates which I am going to discuss in this video. Hi, I am Surajit Ghosh, and in the next 40 minutes, I will talk about the updates in the latest version of STAAD.Pro CONNECT Edition, which is V22 Update 10. Build number is 22.10.00.153. In February, Update 9 was released, and within the next 2 months, another new version of STAAD is available. Probably you are wondering what are the new features and updates in this new version. Do you know there are more than 200 updates in V22 Update 10, and most of those are related to the analysis and design engine, which can change the final results? Well, it is not possible to cover all this in a single session. I will cover only the major updates which are very important for the analysis and design results and overall performance of STAAD, including updates in Indian, American and Eurocode. For other design codes or minor updates, you can go through the revision history file. I have included the link in the description. By the way, if you are using any older version of STAAD, then you can go through my previous video on STAAD.Pro V22 Update 8 and 9. There are several new enhancements in this 2 version, like auto-generation of wind load as per IS 875 Part 3 code, new mass model generator, or implementation of Canadian steel design code S16 2019. You can access it from this playlist. Before going into the details, few additional information. Whenever a new version of STAAD is released, that release information is posted in the newsfeed and we can check it from STAAD interface. As you can see, there are few updates, one of which is related to the latest version. We can expand and check the key updates in the new version from here, or open the post where the major updates are described. In addition to this, update information is also available in the connection client. We can install the latest version directly from here, which require admin right. So you should check with your IT team before upgrading to the latest version. For more information related to update and installation, you can refer to my previous video. As mentioned earlier, there are more than 200 updates and bug fixes in this new version, and I have grouped all this in different categories. I will start with the updates in analysis and design module, cover the updates in user interface including post-processing and member query window, enhancement in physical modeler, and finally discuss the improvement in the interconnected modules like RAM connection and RCDC mode. Let's start with the updates in analysis and design engine, which is very important to understand the result difference with any older version. First, I want to discuss one major enhancement in this version: design of tapered member using Eurocode. In any older version of STAAD, we can design a web tapered member using AISC, Indian or Canadian code, but this facility was not available for Eurocode. If we try to design a tapered member, an error message is reported and program terminates the design without any unity ratio. I am not sure why it was not implemented, but finally in Update 10, this feature is available. Design using EC3 code is implemented for tapered eye section defined from property page or user table, tapered tube and pipe section. Lateral torsional buckling check following the guidelines of Annex BB, which limits the length between the restraints, is implemented. For more details, you can check the help manual. All relevant information like which sections are allowed, which design checks are performed are clearly mentioned here. For any industrial, commercial or utility structure like warehouse or manufacturing plant, this type of PEB structure is very common. In this model, I have assigned few tapered sections with variable depth to the column and rafter member, created a design brief using EN 1993 code with default design parameter. Till update 9, design of tapered member was not possible, but now we can easily design these members and check the unity ratio along with the critical condition and load case from the post-processing table like other uniform section. If you are working in the PEB industry, then I think this enhancement will be useful. Though the tapered members are designed using default parameter, it is not suggested. There are few additional inputs required for tapered member design which we can check from the output file. Few warnings are reported for this, which informs that LY, HGT and EFT parameters are missing and default values are used for design. It is important that we understand why these parameters are used and accordingly specify the value. From the design parameter window, we can get a basic idea about each parameter. More information is provided in the help manual. For example, EFT parameter is used to define the distance between the adjacent torsional restraint, and this value is used for lateral torsional buckling check for tapered section as defined under Annex BB, clause 3.2.2. By default, member length is considered. Similarly, Ly is the distance between the lateral restraints considered for LTB calculation of tapered I section. HGT is a new parameter which is used only for tapered rafter to denote the CG distance of the purlin from the top surface of the tapered section. By default in STAAD, all sections are placed by its geometric centroid, and if we inspect any rafter purlin joint, we can easily notice that the purlin CG is connected with the rafter CG. This placement is not correct. In reality, purlins are placed on top of the rafter to support the roof panel, and we need to assign an offset value to move the purlin. Using HGT parameter, we can achieve the same and consider the eccentricity during lateral torsional buckling calculation. Positive value of HGT means the purlin is moved upwards on top of the rafter. Negative value means it is moved downwards. By default, distance from the rafter CG is considered as 0, but if we want to align the purlin members correctly on rafter, we need to specify a positive value, and same is considered for LTB calculation. These three parameters are required to design any tapered section as per EC3 code. I am not going to discuss any technical aspect in this session. If you need any further information, let me know. Apart from this enhancement, there are few major fixes related to Eurocode. To design any user table general section with a specific type like I, channel or RHS section, we need to specify GST parameter. There was a problem with this parameter. Basic dimensions were not checked properly before design and incorrect section properties were used. This problem has been fixed now. There was a problem with unsupported length calculation for Eurocode along with BS, IS 800-1984, AIJ and few other codes. Unsupported length for lateral torsional buckling is calculated using UNL and UNF parameter, where UNL is the unsupported length of the member and UNF is the length factor. This is equivalent to LX and KX parameter used in several other code. Previously, if both UNF and UNL are assigned to a member, the last assigned value in the design block was used to calculate the unsupported length. Now this logic has been modified and unsupported length is calculated as UNF multiplied by UNL. Just for an example, if UNF is 1.2 and UNL is 3 meter. Previously the unsupported length was considered as 3 meter. Now the value is considered as 3.6 meter. Finally, there was a problem only when Eurocode is combined with BS or AIJ code. Due to an initialization problem, design results were not correct, which has been fixed. That's all from Eurocode. Next, I want to discuss the updates in Indian code. There are several bug fixes related to IS 800-2007, 1984 and IS 801 code. For IS 800-2007, there was an issue only when setZup command is used in the model. Due to different axis orientation, section property and member force values were switched, so major and minor axis force and design results were interchanged. This problem is now fixed, and if you are using setZup command in your model, then you can notice a change in design results only for IS 800-2007 code. For IS 800-1984, there are several updates. For this code, section classification is not required, and any prismatic section is designed using YD and ZD value. If YB value is not available, then compression flange thickness required for bending stress calculation is considered as YD, which was not considered correctly in the earlier version. By the way, prismatic section design is not possible using limit state method, as the section dimensions are not mandatory for this type of section. For a general section, as it is designed as an I section, if any of the I section dimension D, TD, B or TB value is not available, then design is terminated with an error. There is another update for combined stress calculation as per clause 7.1.1a. To calculate the CM value, 3 conditions are mentioned under clause 7.1.3, and this is controlled using SSY, SSZ and CMY, CMZ parameter. In earlier version, if SSY and SSZ value is specified as 1 for no side sway condition, program internally calculates the CM value, neglecting the assigned CM parameter. Now this condition has been modified, and for no sway condition, if any CM value is specified in the model, that is considered for design. This change is to properly consider the last condition when supports are unrestrained against rotation. For such case, we need to specify CM value as 1. For IS 801 cold form section design, there is one update. Design routine has been updated to improve the determination of allowable stress of channel with and without lips when moment is about the minor axis. For AISC 36016 code, there is a major enhancement related to single angle member design. Normally, single angle members are used in a truss as a bracing member, and as per section E5, the effects of eccentricity on single angle members can be neglected and evaluated as an axially loaded member using effective slenderness ratio. There are few criteria which must be satisfied, and program can check this using E5P parameter. Within these 5 conditions, last 2 are internally calculated, but first 3 must be calculated manually, and accordingly we need to specify the E5P parameter as 0 when all conditions are satisfied, or 1 when one or more are not satisfied. In such case, single angle members are evaluated for combined axial load and flexure using provisions of chapter H. There are 2 more subconditions. Condition A, when single angle is used as a wave member of planar truss, and condition B, when used in a box or space truss. This can be specified using IMM parameter. By default, it is considered as a planar truss, but to consider equation E5 3 or 4, we need to specify IMM value as 1. So, if we want to design a single angle section as a truss member, following E5 guidelines, we need to manually calculate these three conditions and assign E5P and IMM parameter. With this implementation, a known issue of single-angle section design is fixed by neglecting the eccentricity effect as suggested in E5. Previously, conservative design results were reported as larger slenderness effect was considered. For deflection check, design routine has been updated to consider the values properly and report correct deflection and corresponding force value in the post-processing and output file. Finally, AISI S100 2016 design routine has been updated for the design of Z with lips about geometric and principal axis. This is to ensure that the effective length of the member accounts for the Ky and Kz factor. That's all from AISC code. There are several other minor updates which you can check from the revision history file. One generic update related to multilinear spring. Previously, there was a limit of maximum number of nodes which can be used for this type of support, and if the support nodes cross this limit, analysis was terminated with an error. Now the routine has been updated to increase the total node number to 1.5 lakh. In the analytical modeler, there are almost 60 updates with some major fix for user table and WinLoad application. Let's start with the user table. When we generate a section in section wizard and import that as an external UPT file in user table, we need to select a section type. Previously, it was not possible to select any section type apart from the white flange section, which is now corrected. Also, if a user table is created without any section information, previously an error was reported during analysis. It has been fixed now and any empty table is removed during analysis. For sections created in general user table with profile points and in section wizard, handling and calculation of centroid distance in different unit system has been enhanced. For WinLoad application, there are few major updates. The routine that was used to identify wind panels has been refactored to improve the zone identification which are subjected to wind pressure load. Along with that, display of wind load panels in the GUI has been updated to improve the identification of contributory area for IS-875 code. Wind intensity value is now converted to proper unit irrespective of base unit setup. With this change, calculation and display of wind load is now more accurate. There are also few changes in the wind load dialog for IS-875 code. This window is now more dynamic, which means if the model is changed after the wind load generation, then also the modified information is updated in the wind load dialog and previously selected data will be stored for future instance. Say we have generated the wind definition for a G+14 story building and later 2 additional stories are included in the model. We can easily use the updated height information to regenerate the wind load without any extra effort. There is another change related to the wind definition. We can specify the wind intensity value for a negative height, which was not permissible before. If a portion of the structure below the base level is subjected to wind load, like a structure on a slope or hill, we can use this feature to apply wind load on that part. For autoload combination, there are few enhancements. In update 9, this window was updated with additional option to include notional load in the combination. In update 10, another option is provided to include reference load during repeat load generation. If a reference load case with proper load type is present in the model, during repeat load generation using autoload combination, that reference load is included in the combination, which is not always required. In older version, there was no option to ignore this reference load. Now, we can simply switch off this option to neglect any reference load from the generated load case and ignore during analysis. There was also another problem with the repeat load. Starting combination number was not working when repeat load case is selected. Loads were added considering the last primary load case number. This has been corrected and repeat loads can be generated from the specified load case number. Along with that, program internally checks the combination number before adding it to the model. If the combination number already exists, an error is reported. There are few modifications related to float diaphragm and seismic load. We can now specify a negative value to the base level of a rigid diaphragm. Rigid diaphragm is necessary to consider the in-plane stiffness of the floor panel during seismic analysis, and if the lowest y-coordinate of the model is not the base level, then we need to specify the actual base level for height calculation. If it is below y equals to 0 level, it was not possible to define it from GUI. We need to enter it from the input editor. Now we can specify a negative value directly from here. For static seismic load as per IS 1893 code, load generation dialog has been updated to display all the options properly and transfer the data correctly to generate the seismic definition. There are also a couple of modifications related to the sequence of command line for float group and analysis command. One final update related to model generation by importing a DXF file. Previously, the origin of the model was set using the DXF coordinate, which is now modified in such a way that any DXF file is imported with the first point located at the STAAD model origin. We don't need to move the model. There are few updates in the graphical interface, and most of these are to enhance the model view. Various view options like view rotation, fit to current window, management of multiple window view has been updated. 3D rendering and full section view of standard, tapered and UPT section have been updated to provide an accurate section information in the GUI. Along with this, internal routine for autosave and auto recovery using .sbk file has been enhanced to improve the performance of the program and to eliminate any unnecessary pop-up window. In the post-processing mode and member query box, few problems have been fixed. For AISC and Canadian code, correct steel design results are reported in the member query box, and information which are not relevant to that code, like CMOI CMZ for AISC 36016, has been removed. There has been significant improvement in the 3D beam stress contour page for castellated, standard, prismatic and tapered tube section. Apart from this, there are several minor updates like few updates for the geometric nonlinear analysis, which I will not cover in this session. Coming to the update and enhancement in the physical modeler, and there are few good enhancements. If you are working on a retaining wall or underground tank structure with tapered wall, then this enhancement might be helpful for your project. In older version of STAAD, it was quite hard to create a wall with finite element mesh using variable plate thickness. Say we want to model a wall with 6 meter height and we want to assign a thickness which varies from 0.5 meter at the ground level and 0.2 meter at the top level. If we generate a plate mesh for this, then we need to manually calculate and assign the thickness at each intermediate node level. And for an irregular mesh, it is tough and time consuming. If we generate the wall first using a single plate element and assign a variable thickness with different value at different node, then the model is generated correctly, as we can check from the rendering view. For more accurate results, we need to mesh the plate, but during mesh generation, program does not calculate the thickness at any intermediate node level and simply assigns the same thickness to all meshed plate element. Once again, check the rendering view. It does not look okay. So Either we need to calculate the thickness manually and assign, or use any custom tool to generate this type of tapered retaining wall structure. In update 10, an option is provided in the physical modeler to create a surface with variable thickness. It is very easy to model a meshed surface in physical modeler. We just need to define the boundary. Program internally generates the plate mesh maintaining proper connectivity with other member and plate element. For thickness assignment, there is a new option to specify a variable thickness. Simply specify the thickness at 3 nodes, which is required to fix the direction of variation, and program assigns this thickness correctly to all internal meshed plate. See, both the rendering and analysis model view represent correct thickness variation. Also, we can confirm the same from the analytical modeler, how the variable plate thickness is calculated and assigned throughout the meshed wall. Anytime we can modify the start and end thickness in the physical modeler, and intermediate thickness will be recalculated. Same option is available in the tank wizard. A new tank module is included in this version where we can model a tank wall as tapered wall. All the loads are automatically calculated considering the variable thickness, and we can further design this wall in RCDC using EC2 code. Along with this feature, there is another new enhancement. Have you noticed this design tab in the physical modeler? No, this is not a new design engine or the default still design engine of STAAD. Rather, this design tab links with the RAM S-beam software, which can design and optimize any type of composite and castellated beam. It is a part of RAM structural system, and finally it is included in STAAD for beam design. By the way, a separate license of RAM S-beam or structural workshoot is required to use this feature. If we model a structure in STAAD physical modeler with wide flange, channel or RHS section, we can export any member to S-beam for design and optimization. Several design codes are available including AISC, IS, Euro and Canadian code. We can select the version and design method along with the available load case. In S-beam, we need to specify the design parameters, deflection and camber information, along with the bracing and restraint condition. Based on this, program finds out the most optimum section required for this member. We can also select or optimize a castellated or composite beam using AISC 360 code. I will not discuss this feature in detail due to time restraint. This will be covered in another session. Apart from these enhancements, there are few minor improvements. More control is provided to create the analytical model with member and plate offset. Additional option is provided to reset the analytical model with current physical model information, ignoring any previous change in the analytical modeler. There has been some improvement related to report file generation and documentation. You may have noticed few problems with report generation in update 9. All those problems along with few other have been fixed in this version. The report setup dialog has been updated to retain the selected load case from a previous instance. For AISC 360.05 and 10, a problem has been fixed to eliminate any duplicate copy of the output in the report. Now we can easily export the entire report to Word file and customize the report as per our requirement. Along with this, STAAD documentation, which can be accessed from the help, contents, has been improved. Several technical items with missing information have been updated, like all the set commands are now properly documented. Do you know we can exclude the nodes from the output file using set note of command, or export the section forces for each mode used in a response vector load as a text file using set rs.txt command. You can check the current documentation of set command for more details. For IS 800-2007 code seismic detailing check, following section 12 guidelines, clause number which are implemented and scope of design is now clearly mentioned in the manual. Few additional verification problems for the latest Canadian and AISI code are also included in the manual. In this regard, I want to cover the improvements related to OpenSTAAD. If you are using OpenSTAAD functions to develop custom template, then you might be aware that the manual is not complete. Several functions are not documented yet. Description and examples are limited. Most of these problems have been fixed in the updated manual. Correct information with example is included. An additional section is provided where the steps to use OpenSTAAD function in various language and platform like C++, C#, Python, VB.NET are clearly mentioned. Apart from this, there are only couple of bug fixes. No new function is added to the library. Finally, I want to discuss about the interoperability and updates in the integrated modules. There are only few updates in the iTwin module which are not that significant. Along with this updated STAAD, latest version of Advanced Concrete Design module, RAM connection and STAAD Foundation modules are provided, and you can check the build numbers from here. If you use any of these modules in your project, then you can notice several new features. RCDC module now supports ACI 318-2019 code for member, shear wall and foundation design. Additional option is available to check the existing foundation design against modified structural force. Different grade of steel is allowed for beam, main bar and stirrups. If you update your STAAD version to the latest, all these modules will be automatically updated to the latest version. No additional installation is required. For integrated connection design module, few problems have been fixed. Orientation of a T-section has been updated to align it correctly with the gusset plate and cleat angle for brace and BCW connection. For apex or knee joint connection, rafter attribute is required, and measurement of angle for horizontal beam-beam brace connection has been enhanced. Now the final question, should we upgrade to this version? Well, this is a major bug fix build with lots of fix and enhancements in analysis and design engine for all the major design codes like Euro, American and Indian code. If you use any of this code for steel structure design, or if you are looking for tapered member design as per EC3 code, then you should upgrade to this version. Also, the new tapered wall feature is very useful for modeling and analysis of retaining wall and underground tank structure. Finally, several crash issues have been fixed along with major improvement of graphical interface and report file, which no doubt improve the overall performance of the product. If you use any STAAD version before update 8, then I'll recommend to upgrade to this version. If you are using update 8 or 9 with any other design code and not concerned about the load generation features like wind, mass model and auto load generation updates, or overall performance of the program, then you can continue with that, though it is not recommended to use any older version. That's all for today. I have skipped several minor updates due to short time. You can go through the revision history file to get more information about those minor updates in this version. Thanks for watching.